Hey everybody, Mr. Bowman here. In this video, we're looking at 2.7 calculus, and our focus is going to be all the merit questions for the 2022 exam. Just a reminder, all of these questions are past NZQA exam questions. I've just kind of compiled them all together. If you're looking for all of the other merit ones from 2015 onwards, check out the link in the description to this video, and you'll be able to see all of those resources there for you. So let's get into question number 43, which is the one we've currently got on the screen. Use calculus to find the values for x in which this function here is decreasing. So before we start, I guess it's good to just reflect on the function here. And I guess the significant part is 2x cubed. So that tells us it's going to be a positive cubic, right? Positive cubic. And from your graphs topic, you should have learned positive cubics look a little bit like that, don't they? And from the function, we can see, from here to there, it's increasing. There's the vertex or the gradient of 0. So from there to there, that's another 0, and there it's positive. But this gap in the middle here is the only point where it's decreasing. So we're trying to use calculus methods to find those. And I guess to put it really simply, it's in between the two turning points. So I'm going to start off with that as my answer. So for a positive cubic, the expression or the function will be decreasing between the two turning points. So now we've got that, all we really need to do is use calculus methods to find these turning points. And we know at these turning points, the gradient, or f dash x, will be equal to 0. So what we need to do is we need to differentiate our function to get f dash x. We can then substitute in our 0. So f dash x for this case, so that's going to be 2 times 3. So that's going to be 6 over 3. And don't forget the power decreases by 1, so x squared. And then we've got plus 6 over 2, and then x, and then minus 20. Simplifying that fractions, that's going to become 2x squared plus 3x, and then we've got minus 20. So now that we've got that, we can go ahead and use our graphics calculator to find out the two values for x, because we now know we can substitute in that 0, and we've got a quadratic equation, find the answer. So x, to find x, a is equal to 2, b is equal to 3, and c is equal to negative 20. When I do that on my calculator, I'm getting x1 is negative 4, and then x2 is equal to 2.5. And I know it's going to be in between those numbers. So f dash x is less than 0 when x is between negative 4 and 2.5. So we're now into question number 44. We've got a cricket match. Basically, they've hit a ball, and that there represents the height. T is in seconds. Use calculus methods to find the maximum height the ball is above the ground. So we know at the maximum height, we know that height dash is equal to 0. So again, we're going to need to differentiate this, set it to 0, solve for t. So h dash is going to be equal to 22.5, the t goes away, minus, was that 9.8 t, and then the 1 goes away as well. Okay, so I now know, I'm now going to set that to 0. So 0 is going to be equal to 22 minus 9.8 t. I can now solve for t. So 9.8 t is equal to 22.5. T is equal to 22.5 over 9.8. And that there means t is going to be equal to 2.296. And don't forget that's seconds. And that there was rounded to 3 dp. So a lot of students in the exam stopped here. But that's really bad because that hasn't actually answered the question, right? It hasn't actually answered or found out the maximum height. So what we need to do is our time value, we're going to substitute back at that into our height formula. And that will then let us get our height. So our height is going to be equal to 22.5, 2.296 minus 4.9 t squared, and that's going to become 2.296 squared, and then we've got our plus 1. Putting that all into your calculator, I'll do it all at one go instead of doing it bit by bit, but that's 26.83 meters, and that there I rounded to 2 decimal points. Okay, so we're now on to question number 45. We're firing through these ones. These ones are nice, short and sharp merit questions, which is good. So basically, we've got find the equation of the tangent for this curve when x is equal to 1. So first step here, the curve there itself, it's factorized. That really limits our ability to differentiate here. So let's expand that, and that's going to become 2x squared minus 6x. Now we do have an end goal of aiming for the tangent, which I always use the equation y equals mx plus c here. I know x, so I know that x is equal to 1. I now need to find out m and y. Y is going to be easy to figure out because I can just substitute that into my original function. But m, I'm going to need a gradient function to figure that out. So let's find one of those. So let's differentiate y to get y dash. So it's going to be 4x minus 6. I'm now going to substitute in 1 to that gradient function to actually find the gradient when x is equal to 1. So y dash when x is equal to 1 is going to be equal to 4 times 1 minus 6, which is negative 2. So my m value here, m is equal to negative 2. I can now finally find the y value by substituting that back into there. So y when x is equal to negative or positive 1 is going to be 2 times 1 squared minus 6 times 1, and that there is negative 4. So now that I've got that, so y is negative 4, I can substitute all of them in to then go ahead and find out what c is going to. So we've got negative 4 is equal to negative 2 times 1 plus c. So that's negative 4 equals negative 2 plus c plus 2 to both sides. So c is equal to negative 2. And now that I've got that, I've got my gradient, I've got my c value, I can put those together to get my tangent formula. So my tangent would be y is equal to negative 2x minus 2. We're now on to question number 46. Forgive me if you hear some background noise. That's my bunny rabbit who's decided to go crazy in a box next to me, but we'll let him be. So we've got a graph here. So it looks like a split or an absolute value graph, and we've been asked to sketch the gradient function, really. So the way I've done this is I've come up with the equation for both of these two lines. So this equation here was y equals negative x, and this equation here was y equals x. And I did that using my, so I know the y-intercept is 0 because they both go through there, and it's both rise 1, run 1, or negative 1 in that case there. So that was really, actually quite nice and easy to find. So now what I'm going to do is I'm just going to differentiate both of these expressions. So that one there will differentiate to negative 1, and that there will differentiate to positive 1. So negative 1 is somewhere kind of along here, positive 1 is somewhere along there. So we're going to do a good job of sketching both of these lines. So let's do with negative 1. And don't forget, it's going to start all the way over here, and it's going to all the way up to the y-axis, but it's going to stop at the y-axis because at that point there, the gradient goes from negative back to positive. So sketching that graph there, so it's going to go all the way along there. And I want to note, because it comes to a point, the very point where they meet, there is no gradient to that point. It's not differentiable. And we're going to repeat the same there. At positive 1, I've drawn that slightly off, but at positive 1, there's no gradient. But anywhere else onwards, or that looks like a bold dot, I better redraw that. So a nice hollow dot, and anything else after that had a gradient of 1. So that wrapped up the merit questions from this video. I think this is the shortest merit video I've ever done. There was 4 really short, sharp merit questions. Hopefully you found them useful. Again, if you're looking for more merit questions to practice on, check out the link in the description, and you'll find a whole bunch of past merit NZQA questions for you to utilize.